Hey everyone, this video is to help you prepare for Unit 4B test. So looking at question number 1, write the logarithmic equation in, log base 4 of 64 equals 3 in exponential form. So as a reminder, to go from log to exponential form, what we do is we start with log of our base, and then we have a number equal to our power. So when we switch it to exponential form, we have our base to our power equals our number. Okay, so in this case, my base is 4. The power would be 3. And it would be equal to the number of 64. So if we look at our answer choices, it looks like it would be answer choice B. Moving on to the next one, write the exponential equation 5 to the 4th power equals 625 in logarithmic form. So it's the same thing. Currently, we have a base to a power that equals a number. So if we're switching it to the other form, it would be log of our base of the number equals the power. So starting off with our base, it would be 5. So we write log with the base of 5. If we look, that would allow us to eliminate answer choice A because it's a base 4, and answer choice C because it's also a base 4. Then we need our number. So our number is on the opposite side of the equal sign. So that would be 625. And it's going to be set equal to the power, which is 4. So we look at our answer choices, and it would be answer choice B. Looking at the next one, which of the following represents f of x equals 1/5 to the x power, and its inverse g of x equals log base 1/5 of x on the same coordinate system? So what we're going to do is we're going to go ahead and graph both of these. So we go to our calculator, we add a new document. No, you don't want to save. We're going to add a graph. First, I start by typing in my 1/5. To the x power, and then I go down and I'm going to type in log base 1/5 of x, and we press enter. So I'm going to put my notes on top so we can see which one it looks most like. So it does not look like answer choice A. It does not look like answer choice B. And it does not look like answer choice D. So it would be answer choice C. Okay. Going back to our notes. Which statement about the logarithmic function graph below is true? So we're looking for the true statement. So let's go through and read them and talk about them. The domain of the function is all real numbers. Remember, domain is left to right. Domain is our x values. Okay, so from the left, it is not going in this negative direction forever. So that is a false statement. So A is not true. The range of the function is all real numbers greater than or equal to 1. The range is our y values. It goes from the bottom to the top, and it's going to keep going down forever and keep going up forever, and that is false. Also, because there's an asymptote at -1 for the x equals -1, it could not be equal to, so that is also why it is incorrect. C, the graph has one x-intercept and no y-intercept. Well, it is correct. There is no x-intercept, but there is a y-intercept. It's right here. So that is a false statement. So false, false. D, the function has a vertical asymptote. Yes, at x equals -1. That is correct. You do need to make sure when you read these that you check that when it says vertical that it is x equals. So that is a true statement. So D would be the correct answer. Sometimes they like to be tricky and say vertical asymptote and make that a y equals. So you have to make sure vertical asymptote is an x equals equation. Going to number 5, which statement is not true about the logarithmic function given below? So the logarithmic function has a base of e and is known as the natural log. Well, if we're looking at it, it is using ln, and ln is the natural log that has a base e. That is a true statement, so that is not what we want because we want something that is not true. The logarithmic function has a base 10 and is known as the common log. Okay, well, we just said it was a base e known as the natural log, so it cannot be a base 10. So that is false. Remember, the common log is just log, and it looks like it has no base. The domain of the function is 3 to infinity, and the function has a vertical asymptote. So if you need to visually see this, we can go to our graph, and we start with a brand new graph, and we can graph it. So the natural log of x minus 3. Press enter. So we do see that it was shifted to the right 3 units, which makes the vertical asymptote at x equals 3. And my domain would be from 3 to infinity, with 3 not being included. So I look at this. That is also a true statement. So it is not C. And it says the range of the function is -infinity to +infinity. The range of all logarithmic functions is that. So that is a true statement. So we don't want that. So that makes our answer B. Looking at the next one, the logarithmic function f of x equals log base 4 of x plus 1 plus 3, graph below, has been translated 6 units to the right, 8 units down to make the new function g of x. What is the equation of the new function? So here we go. First off, let's talk about this right here. This has been moved 1 to the left. So it went to the left 1 unit. And it has been moved up 3 units. Okay? Well, we want to translate it 6 units to the, let's see which way, right. 6 units to the right. Well, look at our graph. Okay? If we're moving it 6 units to the right, that would be 1, 2, 3, 4, 5, 6. That would put it now at x equals -5. Okay, so if I look, it should say x equals -5 because it was +1 and that was to the left, and now we're on the right side. So that would allow me to eliminate all of these answer choices except the correct one of D. But we're still going to talk about it. Okay, now it says that if we think about it the other way, if we have +1 and we subtract 6 from it, that does give me that -5. Okay, then it also wants to go 8 units down. Okay, 8 units down, it's currently 3 units up. So if I think about it right here, going down 8 units, that would be 1, 2, 3, 4, 5, 6, 7, 8. So it should be a -5, which is what that has. Or you can think about +3 minus 8, which would give you a -5. So sometimes visually that might help you, so use the graph if you need it. Looking at the next one, use the properties to expand the given expression. So one thing you need to remember is that when we are expanding, each variable x, y, z, and a will have its own log with it. So if I look at my answer choices, answer choice A only has 1 natural log, so that cannot be my answer because they all have to have their own log. So remember, things on top, well, before we even do that, we need to rewrite this using a rational exponent, meaning an exponent that is a fraction. So what that looks like is the natural log of x to the 7th because this is a cube root and this has a 1, it would be y to the 1/3 power. And it's over z to the 9th, a to the 2nd. Now, things on top will get plus signs or be positive. Things on bottom will be minus signs in front of them. Each thing is going to have its own log. So I'm going to have 4 different natural logs. So the first one's going to go with x to the 7th. Because y is on top, it gets a plus sign in front of it. Then I have the natural log of y to the 1/3. Since the z is on bottom, and that's the next one, it's going to get a minus sign in front of it. The natural log of z to the 9th. A is on bottom as well, so it gets a minus sign in front of it. Now, we see that each one of these has exponents, and exponents need to be moved into the front of the natural log, directly in front of the natural log. Okay, so we have 7 natural log of x plus, that should be a 1/3. I accidentally wrote 1/2. That's my bad, so I'll fix it. So it should be a 1/3. There we go. Okay. Minus 9 natural log of z. Oops. Minus 2 natural log of a. So that's completely expanded right there. We look to see our answer choices that match. Okay, so the issue with B is that when they dropped the exponents out in front, they just put it in front of the variable. Okay, it has to go directly in front of the log, so that is not correct. On answer choice D, it still has this as the cube root of y. It cannot be left as that, so that is incorrect. So C is our answer, and it matches what we wrote down right here. Okay. Now, looking at answer choice, or sorry, question number 8. Condense the expression, that should say expression, convert rational exponents to roots. Okay, so first thing we're going to do is we're going to just work backwards on what we just did. So we start with the numbers out in front. The numbers out in front become the exponents. So we get the natural log of x to the 5th power minus the natural log of y to the 1/2 power plus the natural log of z to the 2nd power. Now we look for plus and minus signs. This has a minus sign, so the y should go in the denominator. This has a plus sign, so the x should go, or sorry, the z should go in the numerator with the x, because the x term, this one right here, is also positive. It just doesn't have a sign in front. So we're going to condense it, which means we're only going to have one natural log. The x to the 5th is going to go on top, and the z squared is going to go on top. On bottom, we're going to have the y to the 1/2 power. Okay, the last thing we have to do is convert rational exponents into roots, meaning we can't have this 1/2 power. So it's going to be the natural log of x to the 5th, z to the 2nd, divided by, what we do is we turn that into the square root of y. So this is the answer choice that we are looking for. So if we look, A is not correct because it has a 5 and a 2. B is not correct because it's the z in the denominator. And then D is not correct because they're not as a fraction. So my correct answer choice would be C, and it matches what we got. Okay, looking at the next one, solve the equation below. So first thing we need to do is we see that we have 2 logs on one side. In order to be able to drop the bases, we have to condense it. So we're going to use the property that says if we're adding 2 logs, we can multiply them together within 1. So I have log base 8 of 9 times 8x. Let me go ahead and color coordinate. 9 times 8x minus 3. And it's going to be equal to log base 8 of 2x plus 3. So what we need to do here is we see that we now have the same base and we have a single log with a single log. So that allows me to cancel out my bases, okay? And I can set what's on the inside equal to each other. So that's what we're going to do. And at the same time, I'm going to go ahead and distribute that 9 to the 8x minus 3. So 9 times 8x is 72x. 9 times 3 is negative 27. And it's going to be equal to 2x plus 3. And that should actually be 62x. So if it's not fixed on yours, make sure you fix it. Okay, sorry, that should be 62x plus 3. Okay, now let me go ahead and fix it here. So if you have a digital copy, it should be fixed. If you have a paper copy, it's probably not fixed. Then we go ahead and we're going to move our x's to one side and our numbers to the other. So I'm going to subtract 62x from both sides. That gives me a 10x minus 27 equals 3. I'm going to add 27 to both sides. That gives me a 10x equals 30. Divide both sides by 10, and x equals 3. Now we go back and we check it in our calculator. Okay, again, this is just to check our work. So we're going to go to a new document. No, we don't want to save, and we're going to add a calculator. So we do menu 3-1 to check our work. We have log base 8 of 8x minus 3 plus log base 8 of 9 equals log base 8 of 62x plus 3, comma, x, and we get 3, so we did it correctly when we worked it out by hand. Okay, so when we type this in, okay, this is how it should look when you go to type it in. All you have to do is type in a 3 right there. You can put it there or you can put it at the end. It does not matter. Since it's positive, you do not have to type in anything there. But if you type in a plus sign, that's perfectly fine. I just typically start closest to this symbol right here, just in case I have more numbers to type in. So that would be our answer. Next one, solve the equation below, round to the nearest hundredth. That means 2 decimal places. Okay, so here we go. We try to rewrite it using the same base, but there's not a way I can rewrite 11 to be the same base. So therefore, I need to change its form. So that's what we're going to do. We're going to change the form. So we have log of our base, which is 8, of the number 11 equals our exponent of 2x minus 15. Okay, so that goes back to question number 1 and question number 2, just switching back and forth between the two forms. So you do need to make sure that you know how to do that. Okay, now all we have to do is evaluate in our calculator. Okay, so in our calculator, we're going to type in log base 8 of 11. Log base 8 of 11. And that gives us 1.15314. So that is what I'm going to write down. Equals 2x plus, or 2x minus 15. I add 15 to both sides. So when I go to my calculator, all I have to do is just do plus 15, and it uses the previous answer, and it gives me 16.15314 equals 2x. I divide both sides by 2. Again, I just hit divide and it uses the previous answer. And I get 8.07657. We only want 2 decimal places, so this 6 tells me to round that 7 to an 8. So my answer is 8.08. Okay. So we can check this in our calculator. We go back, we do menu 3-1. We type it in exactly as it looked. 8 to the 2x minus 15 power equals 11 comma x. We get the same answer, so we did it correctly. So you just have to make sure you know how to round correctly. So when I type my answer into the boxes, again, I start right here next to the plus or minus sign, 8.08. Okay, you do not have to put anything in this box, but again, my suggestion is always starting closest to that box. But you could also, it doesn't matter where you type it in as long as you type in the answer. But this is my suggestion, how I have it written down for you. Okay, number 11. Daniel invests $3,500 in an account that earns 2.3% interest compounded continuously. About how many years would it take Daniel's account to be $9,075, round to the nearest whole number? Okay, so we are rounding to the nearest whole number. So here we go. Because it said compounded continuously, we use A equals P times E to the RT power. We were given P to be 3,500. We were given the rate, okay? And remember, our rate, we have to change to a decimal by moving it 2 places to the left. So our rate was 0.023. And we were also given A, the ending amount, which was $9,075. So I have $9,075 equal to $3,500. Remember, E is a number, and then our rate is 0.023, and we're trying to solve for time. First thing we do is we divide both sides by $3,500. If you want to type that into your calculator to simplify, you can, or you can leave it as is. It does not matter either way. Just simplifying it gives you less numbers or smaller numbers to work with. Okay, so we're dividing because we want that e to the power all by itself. That way we can switch the form to get that exponent out of the exponent spot. We just want it to be a normal number. So because it's a e, that means we switch it to the natural log of our fraction. So $9,075 divided by $3,500. And we set it equal to the exponent 0.023 times t. Then I divide both sides by 0.023. to get t by itself. And now this right here is what I type into the calculator to solve for t. Remember, we want to round to the nearest whole number. So I go to my calculator, I start with my fraction button. In the numerator, I have the natural log. Within the natural log, I have an additional fraction. So that would be 9,075 divided by 3,500. And then I have divided by 0.023, and I get this. So rounding to the nearest whole number, that 4 tells me to keep it 41. So my t would be 41 years. It would take 41 years for the account to grow. So when we type that in, it would be a 4 and a 1. So, looking at the next one, solve the equation below. Write your answer in logarithmic form. So notice our answers are all in log form. So we see if we can rewrite it. We can't. So we're just going to go ahead and switch the form. So we have log base 2 of 512 equal to our exponent negative 9 minus x. Okay, then I'm going to add 9 to both sides, and I get log base 2 of 512 plus 9 equals negative x. Then I need to divide each thing by negative 1. So I get negative log base 2 of 512 minus 9. The negative cannot affect the 512 because it's attached in the log, it's on the inside. So we look at our answer choices. We can eliminate answer choice D because it has a base of 9. We can eliminate answer choice B because it says 503. Okay, so then we just look at A and at C, and we need them both to be negative, so C would be our correct answer. Okay, last question. Which statement is true about the exponential function 1/7 to the x power plus 2 graph below? So the range is 2 to infinity. Well, remember, range is our y values. It goes bottom to top. It does start at 2 and it goes up. 2 can't be included, so that is a true statement, but let's keep reading. The x-intercept is 0, 2. There is no x-intercept, so that is a false statement. The horizontal asymptote is x equals 2. The issue is that it says x equals, that should be a y, so that is a false statement. And the y-intercept is 0, 2. Actually, the y-intercept is 0, 3. That is a false statement. So A is our correct answer. So if you have any questions on the video, please make sure you ask before the test. Good luck, and I hope you all do well.